Hello, Dynamics. Uh, Last class we looked at work equals changing kinetic energy, and we looked at that for the case of a solid object. So we tried to figure out what the kinetic energy of a solid object would be. Uh, in today's class, we're going to look at the impulse equals change in momentum version. We're going to look at the angular momentum version of that. Okay, to start though, we have to derive a expression for angular momentum of a solid object. Of course, angular momentum of an individual particle is this equation up here that we've used before. But in the case of a solid object, we have to consider not just one particle, but we have an infinite, or not, maybe not an infinite, but we have an awful lot of individual atoms and electrons to calculate the angular momentum for. So we have to figure out the angular momentum of the whole solid object by adding up the angular momentum of each individual particle. So that's what this is. This is just saying the sum of the angular momentum is this expression for each particle all added together. Okay? And to expand this out and figure out what our answer is going to be, first we'll take this vector, which is the distance from particle I to point O. That's an O, not a G. Let me just make sure that's really clear. That's an O. So I want the distance from particle I to point O cross the mass of that particle times its velocity with respect to point O. So let's take this and write it as the distance from point I to the center of mass plus something else. And let's take this velocity term and write that as the velocity of the center of mass plus something else. And I'm going to let you fill in those something else's. Then when you multiply this out, you're going to get 4 terms. Okay? And it's your job to simplify each of these 4 terms. As a hint, though, use this relationship that the sum of the distances from point R, or excuse me, the sum of the distances from the individual point I to point O times those masses, that equals the location of the center of mass, and that's the location of the center of mass compared to point O. So that's basically point G compared to O times the total mass. So I'd like you to try to simplify those 4 terms and find an expression for angular momentum. Go ahead and do that before you try to watch the next video. So it might take you 10 minutes. And go ahead and jump on the